Alright, so in this video I'm going to talk a bit about significant figures and the rules that we use in physics to determine how many significant figures we should give. But before we get to that, let's start with a question. What is 40 divided by 10? So just grab a scrap piece of paper or write it on your computer. What do you think the answer to this question is? Okay, so my bet is that you have written down 4, and anyone who's learnt basic maths probably would also have written down 4, or if you haven't written anything, you'd thought of 4. However, you are wrong, and you're probably like, no I'm not, I know basic maths. Well, actually you are, and especially in terms of A-level physics, it's really important that you recognise why. So, without further ado, let's talk about significant figures. So we've done a question, we've done lots of calculations, maybe we're using velocity and time, and we've got the answer 5.0 meters. So when you give 5.0 meters, you're not just giving an answer, you're also telling someone reading it about the calculation that you've done. And what you're actually saying is that you are confident that your value is correct, and it's between these values, the 5.05 and 4.95, because any number between these two numbers would get rounded to 5.0. So that's what you're saying by giving your answer to that many significant figures. However, if say you'd given that 3 sig fig, which they often will in maths, 5.00, what you're actually saying is that you can be precise to 5.005 or 4.995, which is considerably more precise. And you're actually lying to the person who's reading it, which is a massive problem in science because it's a very international subject. Stuff is shared across the globe, and you need to follow the rules that every scientist is using. So what are those rules? So first thing we need to recognize is what is a significant figure. So it's essentially the number of numbers that you give an answer to. It's a little bit more complicated than that, but anyway. So say in an example we're going 5.0. Ooh, that's really chunky. Let's reduce that a little bit. Okay, so we start from the left. Here's your first significant figure, here's your second significant figure. So this is 2 sig figs. Okay? However, it tells you here that preceding zeros are not significant. So if we'd given an answer like this, this doesn't count as it's. That's a preceding zero, it's not significant. Whereas, say we gave this answer, then this zero is significant, and then we've now got 3 significant figures. So that's essentially some rules you need to know about how you use zeros. So preceding zeros, or zeros before the first non-zero number, are not significant, all other ones are significant. Okay, so let's have a look at the rules that we're going to follow in calculation. So when you give your answer to a question, the answer should be to the same number of significant figures as the piece of information you used in your calculation with the fewest significant figures. So that's quite a mouthful, so let's have a look at an example. So we've got an object travelling 10 meters in 20.0 seconds. And if you want to calculate the velocity, just distance divided by time, so it would be 10 divided by 20.0. And that will give an answer of 0.50, which is the 2 significant figures, because this first zero is not significant. So why is it given to 2 significant figures? Let's look at the information you've been given. 10 meters is to 2 significant figures, 20.0 is to 3. And the rule is that you use the fewest number of significant figures you've got. So the smallest is 2, which is why we give the answer to 2 significant figures. Now, as a little side note at this point, later in the course you're going to encounter quantum numbers and other values which you know are integers. So let me give you an example. That's not a good example. So if we want to calculate the circumference of a circle, you do 2 pi r. Okay, so if you type them in your calculator, this number and this number here will be two infinite significant figures. So this, we know it is exactly 2. We don't not think it's 2.0 or 2.00. We know it's 2.0, an infinite number of zeros. We know that. So this is an infinite number of significant figures, and pi also is to an infinite number of significant figures. So the thing that's going to limit you is going to be the radius that you have measured. Okay, so that's your basic rule. There are, however, as always, some exceptions. So, you never give an answer to one significant figure unless you know it's an integer number like 1 or 2. You just don't do it. You don't give one significant figure answers. If you're in a position where the rules tell you should give a one significant figure answer, give 2 significant figures. So like this one here, if it's travelled 10 metres in 5 seconds, we give 2.0 metres per second. We don't give one significant figure there, we give 2. Okay, so let's revisit the question I posed to you at the start. What is 40 divided by 10?